2.4, how can I describe a graph? Describing a graph, what does it mean to describe a graph completely? Today we'll describe a variety of graphs and remind yourself of vocabulary that you have previously learned. So describing a graph, today you will need to describe graphs completely in words so that your classmates can accurately sketch the graphs without seeing them. But first, together with your team, create a list of questions you will ask yourselves when you see the graph. You should create a set of questions that when you answer them will be reading is so difficult for me, that when you answer them will completely describe the graph. So think about graphs you made in previous courses and how you describe them. Be prepared to share your list of questions with the class. So ultimately what happens is this in this lesson, that each group ends up getting a shape, and they get that shape that none of the other groups gets it, and they have to sort of describe that shape to the rest of the class, and the rest of the class kind of draws what they think it should look like and kind of goes from there. So when we do that, the first thing we do is sort of brainstorm what would be some things that you think would be good ways to describe a graph. And here's the list that the book came up with, and usually it's pretty good. The class does a pretty good job of coming up with the similar kinds of a list. A shape, what shape is it? Does it have a line of symmetry? Is it increasing or decreasing? Is there an asymptote? And again, an asymptote means it kind of gets closer to something and never quite touches it, like exponential decrease or increase, actually, to the left. Are there intercepts, x and y intercepts? What's the domain and what's the range? Does it have a limited domain and a limited range, or an unlimited domain and an unlimited range? Can it be all the x values and all the y values or not? Is it continuous or discrete? Again, continuous meaning that you connect the dots. Discrete meaning it's dot to dot to dot. Again, all this vocabulary came up and integrated in one. So hopefully you guys remember this stuff. The continuous, excuse me, or discrete came up with sequences when we talked about those. And is it a function or not? Is there one input for each? Is there one output for each input or not? So I think maybe we've described most of these. A line of symmetry, if you don't remember what a line of symmetry is, that's like if you cut it in half, would it look the same to the left or to the right? But that's the kind of list that typically students will come up with, and then they'll get a shape. So if they got a shape like this, they might say on shape D right here, they might say that the domain is 0, 1, 2, 3. So like the whole numbers, right? There's no negatives, there's no decimals. The range would be 0, 1, 4, 8, 9, etc. And then they would probably say it's discrete, right? It's skipping from one to the other, that it is increasing, it's curved, it's not linear. These would be some of the ways that you could describe the shape. So again, that's really what we're looking at, is each group will get one, do the best they could to describe it. Maybe if they got graph H, they would say, the domain is greater than -3 or equal to -3. It makes a V shape. It has an x-intercept at 3, and at -3 it has a y-intercept at 0, -3. It's continuous in both directions. Those would be the kinds of things that they could talk about. The domain is unlimited. I might have said that backwards earlier. I apologize if I did. The domain is unlimited, but the range is greater than or equal to -3. So I apologize if I made an error there. But hopefully you get the idea. So we're going to create a detailed and complete description of the graph they've been assigned. Then we kind of share that description. The different groups draw them, and we just see which group did a good job of describing the graph or not. It's kind of fun in class, nothing too serious. All right, so now what we're going to do is we're going to match each scenario. And let me open this over in here. Do I have this open? I do. Okay. So it says match each scenario to a graph that it could represent, then sketch the graph, label the axes appropriately, and write a description of the graph. So the price of a postage stamp over 20 years. Well, did it go up and come back down? I would say no. Did it get cheaper? Probably not. It stays at a price, then it jumps to the next price, then it jumps to the next price. So I would say that there's a decent chance that this would match with this graph right here. All right. The number of hours of daylight each day over a year. Well, does it go down and never come back up, that would be depressing, right? So here, maybe this is spring, and then it gets more, and then we get to summer where it's very sunny, and then we get to fall, and then towards winter. So I would say this goes with I. And then the value of a car over 10 years, it loses a lot at the beginning, and then it sort of levels out. It's still not going up, but you're not losing as much as time goes by. So I would say that match goes to I. Now, they would have you graph it, and again, they said, this would be time, and this would be money or value, right, of the car. And then what we could do is we could go through and say, like, I don't know, maybe this is $20,000 and this is $10,000 and this is $5,000. Just come up with the scale. So it was asking us to do that for the following. 160, it says Frank's teacher asked him to write descriptions for the graphs below. He has written 3 short descriptions. Are Frank's descriptions complete enough to determine which one goes with which graph? So we got another matching here. Let me go ahead and set this up. Okay, so he's described the graph using these 3 things here, and now we're going to see if this matches any of them. So first of all, he says it's discrete. Well, this is continuous and this is continuous, so it can't be 2 or 4. It's linear and increasing. Well, I think we're done, right? Oh, I see what's going on. I think I didn't realize each one was its own description. I thought they all went together. So my mistake. Whoops. Okay, so let's try that again. It's discrete. Well, there's 2 choices here. So I would say no. I don't know which one we're talking about. It's a linear and increasing. Well, this is linear and increasing. So is this one. So that one, I have a choice between 2. It's a nonlinear and it's decreasing. Well, yeah. So Frank's not doing the greatest job. Again, I apologize for my mistake on that. I thought these 3 described one graph, and it kind of got confusing because after 2 you would have been done, but of course that's not the case. All right, so that's, again, the idea behind lesson 124 is just to be real descriptive when we name these graphs. And again, I think that this is a great list to sort of have handy when we go through and make this list. These are the kinds of things that we want to keep in mind. What shape does it make? The line of symmetry, can you cut this thing in half to make it look the same either way? Is it increasing or decreasing? Is it going up or down from left to right? Is there an asymptote? Does it get close to the x or y intercept without actually touching it? Or does it actually have intercepts? And if so, what are those intercepts? Does it have what's a domain and range? What are the x values it can be, and what are the y values? And is it limited to certain domain and certain range? Again, is it continuous or discrete? Continuous means we connect the dots. Discrete means it goes from one dot to the next. And is it a function or not? Does each input have exactly one output, or maybe it has more? So those, like I said, I really like this list. It's something to think about.